We're the automated indoor garden team. So I'm Will Smith, I was the team leader, and I did a lot of the software design of the controller. Thon did a lot of the website software design. John Yu and Daniel Chan are both working on the hardware. So as urban populations continue to rise, less and less people have access to fresh vegetables. And so whenever a large populated area doesn't have a grocery store in a reasonable distance, it's considered a food desert. And this is actually an issue that affects like a large area in like South Dallas, just here in our own city. So our system allows anyone to grow their vegetables hydroponically by automating the most difficult aspects. And we believe that growing vegetables hydroponically is beneficial because on average, the returns are a lot faster than traditional garden growing. So to facilitate life in a hydroponic system, there are 5 things that need to be maintained. In the water, the nutrient concentration and the pH need to be correct. And in the air, the temperature and humidity needs to be correct for whatever plant you're growing. And then you need to have light to simulate sunlight and produce photosynthesis. So for the hardware of our project, first we're using NFT, a nutrient film technique hydroponic system. So there, we have these PVC channels that the roots sit in, and there's always water constantly recirculating from the tubes into a reservoir down at the bottom. And then for our electronics of maintaining the water, we have a pH probe, which is in the water, always probing the pH. We have an electroconductivity sensor, which helps us read the nutrient concentration in the water. And then we have an E-tape liquid level sensor, which is basically a variable resistor that tells us how high the water is in the bucket. We can use that to calculate how many gallons are in the system. And so those sensors are all attached to our analog to digital converter on the I2C bus of the Raspberry Pi. We use to probe all those sensors. And then for the main enclosure, it's in a tent, which is 32 inches by 32 inches footprint and 63 inches tall. And then we have an LED light. We use LEDs because they produce the least amount of heat from all the different kind of grow lights. So the LEDs are red and blue because when the specific wavelengths that the LEDs produce, red and blue are what best promote photosynthesis. So we have an exhaust fan that's always porting heat out. The LED tends to produce a little bit of heat, but it's not too much. So we're always pouring air out, and the environment works with a passive air intake unless the heat were to rise. We do have a temperature and humidity sensor, which is also on our I2C bus. And we have an intake fan that we can turn on to bring cool air in, or we have a dehumidifier that we can turn on if the humidity gets too high. And then, so for the software, all of this is running on a Raspberry Pi, running Linux. We have a Python controller that feeds automatically on a weekly schedule. It'll put nutrients in the water, or it can detect when you add more water into the system and nutrients need to be re-added. It monitors the pH to make sure it stays within the bounds. It's always checking, but it generally only needs to be adjusted a couple times a day. And then we have different light configurations. So when you're at the very beginning of your plant, you can either have the light on 24 hours all the time to just have it always growing, or you can move it to like a 6 on, 2 off if you want to have majority growth, but maybe give it a little break. And then when you're moving into like actually flowering something, like if you're growing tomatoes or something that was photoperiodic, you can then move it to like a 12-12, 12 on, 12 off. So we have a database, a MySQL database that we're logging out all the readings into just about every 10 minutes. And then in the database, it also has information about like the plants you're growing and what the ideal conditions would be, your active grow, how long it's been going, and stuff like that. And then we also have a website, Apache PHP server that acts as the interface to the garden. So we have a live stream that you can look at to see, and then you can view the logs from the database of what the pH and temperature have been. And then we also have some basic controls, mostly just kind of for this demonstration, so we can turn the light on and off so you can better see the plant because the red and blue lights tend to kind of distort the colors. Is there any questions?
Tell me again what the size is.
It's 32 inches by 32 inches is the footprint, so that's just about like a 2.5 feet, and it's 63 inches tall, so I think it's just about like 5.5 feet tall.
So how much could you actually grow in there?
So for our demo, we have these 3 NFT channels, and we have spots for 6 plants. We could probably make it up to 9, but this is just kind of a proof of concept. We could change it. We could put more channels in. So you could probably have maybe around 12 plants growing.
Well, how big are plants? I mean, tomatoes come in little pots and they come in, big garden
Yeah.
size too.
I guess it would really depend. If you're growing tomatoes, you probably want to have some kind of wiring for them. With our lettuce, I guess the size wasn't too big of an issue.
What does this cost?
So with everything that we bought, we were just a little over $1,000, but we did buy a lot of PVC that we ended up not using. So I'd say it's probably pretty close to around $800, $900 altogether with just the parts that are in the garden.
So you have sensors, and then on the front end you have effectors putting nutrients and controlling the pH.
Mm-hmm.
Are those mapped to each other in a fixed way, or does it learn anything over time?
It's really just mapped in a fixed way right now, but since we're always reading, as it goes, we could improve to know kind of what the nutrients, once we have more readings to expect what the nutrients are going to do over time, then we could have it more.
So do I have to calibrate this if it's in my sunroom versus if it's in my bedroom, or is it smart enough to work?
It should calibrate automatically like that.
Okay.
And it's all enclosed up in itself.
Okay.
Do you have a way to handle like pesticides or?
Generally, since it's indoor, pesticides aren't a huge problem. I guess we have like the camera where we can go in and look in it. We haven't come across any issues with pesticides yet.
So it exhausts the air inside your home?
Like I said, it's exhausting the air. I guess it would just be in your home. You'd have to have some kind of port to take it outside.
How does the system compare to, say, some of the little grow thing, you can get the little mini garden grow?
Yeah.
I understand for soil, but how does that compare as far as what you can actually produce?
Well, generally when you're growing hydroponically, I believe, I don't know what the exact number is, but I think things on average grow about 25% faster, and they generally grow, I think it's about the same, about 25% bigger. I'm not exactly sure on that bigger part, but I know generally when you're growing hydroponically, your plants do grow faster and bigger from traditional soil growing.
And have you compared the cost of, a hydroponic system? I've thought about building a hydroponic system, which is,
Mhm.
pretty cool, but, they're gonna pay for themselves.
Mhm.
It's just a hobby.
No, I guess we haven't really done. In the very beginning, we were determining whether we were going to go hydroponic or soil, and we decided that hydroponic is what we wanted the system to be.
Because?
Just because of the faster growing returns, and also, I guess it just gave us an opportunity to use more sensors into the water, as opposed to only having like just a moisture sensor to check to make sure it's always moist.
So as part of your testing, what did you grow, lettuce?
Yeah, so we grew lettuce, and so I think we've grown we had 3 different rounds in the beginning, and our first 2, they all died. We were having some issue with our pH probe. We probably need to get a more expensive pH probe than the one we used. It would have less drift. But there are currently 2 of the 4. We started all the lettuce we bought from Home Depot in soil, and we washed all the dirt out of the roots and then transplanted it into the system to try to kind of buy us some more time. And there are 2 that have been growing for over 2 weeks. I think about 2.5 weeks today.
And that is actually our live stream snap that we took from our website.
Say again?
Oh, that's actually the pic that we took from our live stream camera.
Did you have a question?
Yeah, so you say you're using a pump to provide the nutrients and the pH control. I guess I've never seen it in like a liquid form. You just have like a tank that's...
Yeah, so we're using these nutrients. They generally come in like 3 sets. The company's called General Hydroponics, so it's specifically for hydroponics. So there's like a grow solution that it's like the NPK, the nitrogen, potassium, and I forget what the third one. But those 3 elements are the main nutrients, and so each bottle has a different ratio of those 3, and then it'll tell you depending on what stage. If you're in like a seedling stage, you're going to use certain combinations, and if you're in like a heavy vegetative stage, you use more different combinations.
Okay, that's, thanks, team.
Thank you.